Good morning, everyone. Welcome to Method Test Prep's Test Prep Time Live. We're once again here this morning at 11 a.m. We'll be doing these short videos every day of the week at 11 a.m. on our Facebook page. So join us tomorrow. My colleague Kevin Dennis will be demonstrating some strategies and insights and concepts for the SAT and ACT. Hopefully you were able to catch a few of the ones earlier this week. These can be really helpful and insightful, short instruction on certain concepts that show up a lot on the SAT and the ACT, trying to give you a lot of value with these concepts and ideas that you can apply to a lot of questions on the test. These will also be posted to our website, so come back, you can view these videos later on. If you have any questions, you can chat some in. We'll look at that towards the end. And hopefully this can be helpful for everyone. My name is Oliver. I'm the Director of Tutoring at Method Test Prep. I've worked with a number of students, private tutoring and class instruction, both the math side and the verbal side of the SAT and ACT. Today I wanted to talk a little bit about a very common math concept that shows up on both the SAT and ACT, and that's called system of equations. And I wanted to look at an example or two and try to highlight some of the important items to pay attention to when you come across these questions. Now first, we have to start with the basic idea of what a linear equation is. Hopefully you have some background in this. We've talked about this a few times previously, but just to review very shortly, a linear equation is an equation in which the change across time is happening at a constant rate, known as slope, and the line crosses the y-axis at a specific point, known as the y-intercept. So a linear equation usually looks something similar to the equation at the top of the screen here, where we see y equals mx plus b. M signifies the slope of this line, or if you want to think about it like the gradient of the line. Now, slope is defined as the change that I move vertically for every point that I move horizontally. So slope can be defined as the change in y over the change in x. So as I move from a certain point up, I go up a certain amount as I go over a certain amount. And I do that once again and again. And that's how I form the slope of my line. And in the example I have here, the slope is 2. And that means that I'm going up 2 units for every 1 unit I move horizontally. So a slope of 2 means a slope of 2 over 1. Now the other part of the equation that's really important is the y-intercept. The y-intercept is the number that's a constant with no x or y value next to it at the end of the equation if you arrange it in this form mx plus b. The y-intercept, of course, is where the line crosses the y-axis. So it's a specific point where it actually intersects the y-axis. In the equation, it's the place where x equals 0. So if you wanted to find out what your intercept is, you could plug in 0 for x because at that point, right, the value for x is at the origin along that line. And so the point you would put in for x would be 0, and then you could find out what your intercept is. So this is just a basic overview to look at what a linear equation is and the parts of a linear equation that we need to pay attention to. What I wanted to talk about today a little bit is something called system of equations. Now, these come up very often on both the ACT and the SAT. It's a concept they're very fond of, and they show it in a variety of different ways. It can seem a little unfamiliar if you don't have a background in this. They do try to present it in somewhat clever ways to hide what they're showing you. But I wanted to start with a basic example so we can get the fundamental concepts here before we look at a slightly more detailed example. Let's keep it really simple as much as we can on this test. A system of equations is really just a fancy way of saying I've got two lines and I need to find out where these two lines cross. So a system of equations can apply to different shapes like circles and ellipses, but for the most part, you're going to encounter a system of equations dealing with just two linear lines or two linear equations. Now here you can see I have two lines. I've marked the red line with the equation y equals 2x plus 1. And I have a different line. The blue line is y equals negative 3x plus 6. Obviously, please forgive my picture. It's not exactly to scale, but you get the general idea. One has a positive slope. It's moving up the mountain as I move from left to right along the x-axis. The blue line has a negative slope, negative 3. That's sort of descending as I move horizontally along the x-axis. At some point, these two lines inevitably cross, and most lines in the world do cross unless they are parallel lines. We'll save that for another day. But today we're looking at typically two lines that cross at some specific point. Now, another thing to keep in mind is that any line, any linear equation, the line is actually showing us visually all the solutions to that equation. So if I wanted to find out what this line looks like for this equation, and I looked at any particular point, if I put in 1 for x, I would get 2 times 1 plus 1 is 3. So I have a point on this line. If I did that again for another point, and then I connected all those points together, that would be this line. So the line is a visual representation of all the solutions to that equation. Similarly, this blue line is showing us a visual of all the solutions to this equation. Therefore, the place where these lines intersect on the graph is also the place, the one solution, whatever the coordinates of that dot are, or that spot, whatever that coordinate is, will be a solution for both of these equations. It will solve both of them. There are a variety of solutions to the first equation, there's a variety of solutions to the second equation, but only one magic spot will solve both of those equations. Now, if you have a nice picture in front of you, maybe even nicer than this one that I drew, and you had all the grid marks and the exact scale and units, maybe on a graph sheet, then you could potentially look at the picture and find that intersection point. But let me already warn you, that's going to be pretty rare. It's not often that they're going to give you a full picture of the two lines. More often, the case will be that you'll simply get the equations of the lines. Now, as we saw earlier, in a line equation, we have a slope and an intercept. And that's how you identify you're dealing with a linear equation. Now, if I want to find this exact point where these two lines intersect, what I'm really finding out is where these two equations are equal. So one way to solve, and probably one of the simpler ways to solve a system of equations, is to set your equations equal to each other. So let's do that now. My first equation is 2x plus 1. My next equation is negative 3x plus 6. Again, just to show you how this maps visually, the first line starts, the intercept starts at 1, and then it goes up 2 over 1 for the slope. The second line starts way up at 6, but it descends from there pretty rapidly. It goes down 3 for every 1 over, hence a negative slope. What I want to find now is this point where they intersect. So I'm going to set my equations equal to each other. Since they were already both in the form y equals something, I know that both of these now equal the same thing, right? If this equals y and this equals y, both of these equations can be set equal to each other. All right, now we just do some simple algebra. I want to get the x's to one side and everything else to the other. So I'm going to add 3x. I don't like negatives hanging around. They usually trip me up, so I get rid of them as quickly as I can. And I'm going to add 3x here. On the left, 2x and 3x give me 5x. On the right, negative 3x plus 3x, those cancel out to 0. On the right, on the left side, I have to bring down the 1, and on the right side, I've got the 6. Now I'm going to subtract 1 from both sides to get my x's alone. I end up with 5x equals 5. And dividing both sides by 5, I quickly find that x equals 1. Now, if the question had asked me what does x equal at that point, at this point, I would be done. But most times the question is going to ask you for the full coordinate, meaning you need both the x value and the y value. So I found the x value, but how do I find the y value? Pretty simple. I take my x value now and I can plug it in to either of my equations that I like. Since this will be a solution for either one or both, I can try out in either equation. I'm going to plug this back into the first equation. So therefore, I'll get y equals 2x. Now my x I'm plugging in is 1 plus 1. 2 times 1 is 2 plus 1 is 3. Aha, my y value there must be 3. So my coordinate at this point turns out to be the values 1, 3. So I have found the intersection point of these two lines. I've also found the shared solution for both of these equations. And if you wanted to, you could plug that back into both equations and you would find that it solves both equations. So once again, a system of equations is just two lines where they intersect, and you're finding that point of intersection. Algebraically, it means perhaps setting them equal to each other so you can find out what one value is, the x value, and then plug that back into either equation to find your y value. Let's look at one more example. I'm going to pull an example right now from our ACT Math Quick Guide. We have guides for every section of both the SAT and the ACT. These are tremendously helpful. I know as a teacher, I use these guides almost every day. They're great in focusing on the key concepts and strategies that you need as a jumping off point for that section. And it can help you focus in on exactly the type of questions and the type of concepts and the strategies that you can use to ace those questions. We have a section for each, a guide for each section of both tests, and you can find it within our self-paced web program under resource materials. If you click there, you'll see all the review packets and guides that we have. Okay, just going back for a moment to the linear equations. We talked about linear equations consisting of a slope and an intercept, m and b. But when we get out into the real world, meaning we're not on the imaginary coordinate plane now, but now we're out there trying to maybe rent a car or choose a phone company, we don't want to tell the guy in the store, hey, we want to find a really good slope or y-intercept. They'll think we're crazy. So when we get out into the real world, and this can be very helpful on word problems on the SAT and ACT, we actually want to think of slope instead as being the rate. So this is like the rate your gym charges you, or the rate the car company charges you, or Enterprise, or the rate that Verizon is charging you. How many cents per minute, or how many dollars per hour. Slope becomes rate. The y-intercept, or the B term, can be thought of as the initial fee or set fee. So this is like the sign-up fee, right? If you join, it's $10 to join and then $1 an hour after that. Or think of it as the starting point of your line or the starting point of your graph. Now that's going to be helpful in this next question because we're going to look at different rates for two companies trying to remove snow from your driveway. I know that my friends in Massachusetts got about 5 inches a couple days ago. I think a couple other parts of the country did as well. This might be something that you need to do. Call someone up to remove the snow and you want to decide which company to use. Now, going back for one moment to the idea of system of equations. What I want to point out here is oftentimes on these word problems where we have to choose between two companies, renting a boat or choosing a phone company, really what we're doing is a system of equations once again. We have two companies And let's say this on this example, the red line starts at 1, but it goes up pretty quickly with a slope of 3, or a rate of 3 over 1. So my line is going to shoot up pretty quickly, and it's going to increase at a faster rate than this line. The second blue line starts higher up, so the initial cost or fee might be higher, but eventually it levels out a bit. And so at some point, some magical place, the blue line is going to end up being less than the red line. And that magical place, once again, is the intersection of two lines, or the shared solution to this system of equations. Again, I would set these equal, solve for x, plug that value in back to either equation to solve for y, and I would have the coordinates of this point, which would tell me the exact moment when the blue line becomes more affordable or a cheaper option. Using that concept, let's take a look at this question from the study guide. To shovel snow from a driveway, author charges an initial fee of $12 plus an $8 per hour fee for every hour or fraction thereof that he shovels. Lolita charges an initial fee of $20 plus a $5 per hour fee for every hour or fraction thereof she shovels. For how much time would the two need to shovel a given house's driveway for Lolita's overall fee to be cheaper than Arthur's overall fee? Let's pay attention to some key phrases in this question. And I find this to be tremendously helpful when I'm working on a math section of these exams. I read the question through once, try to understand a bit, but then I go right back and I start underlining the key phrases and the key elements that I need to focus on. First, we have one company, Arthur, and another company, Lolita. They both charge different amounts. Arthur charges an initial fee of $12. So if I were to write an equation for Arthur's company, let's say Arthur's amount is going to include an initial fee. Now, if you remember from the generic linear equation mx plus b, we said that the m is known as slope, but in the real world, we want to think of the m as the rate. We talked about the b as a y-intercept, but in the real world, we want to talk about the b as the starting point or initial fee. So for Arthur, the initial fee is 12. That's going to be my intercept, or b term. Plus an $8 per hour for every hour. So his slope or his rate is $8 per hour. And you can see a linear equation. Let's go to Lolita. Lolita charges an initial fee. Again, these are the key words to pick up on. If you see that initial fee of 20, don't even hesitate. You've already got the first part or the second part in this equation. Lolita starts at 20. However, her rate fee per hour is $5. $5 per hour. So you can see Arthur starts a little less with 12, but his rate goes up pretty fast per hour. In Lolita's case, she starts with a higher fee at 20, but her per hour rate is 5 hours. So going back to the last slide, there's going to be a place, let's imagine this is Lolita and this is Arthur. Lolita may start higher up, but at a certain point her rate or slope is less, so she's going to be less overall. Whereas Arthur starts at a lower point, but eventually he is going to get much higher. So I want to find this magical spot where Lolita is going to be cheaper. Going back here to the problem, I can simply do that as I've done the last two times by setting these equations equal to each other. So we're going to put Arthur on the left equal to Lolita on the right. Okay, let's solve for h. What we're solving for is what time or how many hours will it take before Lolita would be cheaper than Arthur's overall fee, so the final total cost. All right, once again, I'm going to subtract 5h from both sides, get my h's together. On the left, I end up with 3h plus 12. On the right, the 5h's cancel out, and I've got 20. I'm going to subtract 12 from both sides, and I end up with 8 equals 3h. Divide both sides by 3 to isolate the h, and you get 8 over 3, which in your calculator would be approximately 2.6, repeating. So how many hours? Well, somewhere between about 2.5 hours, so somewhere between 2 to 3 hours. Somewhere in that range, Lolita's price is going to be cheaper. So at this point, we've just discovered the hours, or the x value, will be somewhere between 2 and 3 hours. So if we go to our answer choices, they don't have exact numbers, they give us ranges. Here, it's C. Somewhere between 2 and 3 hours, Lolita's price will be cheaper. If we're going to be shoveling for more than 2.5 hours, we want to pick Lolita. She's ultimately going to be the cheaper price. So hopefully this can help decipher some of these word problems where you're having to choose between two companies or two different rates. You can understand now that a linear equation is showing you the starting point is your intercept and the rate is your slope. If you can identify those parts in a word problem, you can come up with the equations. And what we were asked here to do was similar to any system of equations, where we're setting the equations equal to each other to find out the x and y value that will solve both equations, also known as the intersection point of the two lines. I guarantee you're going to see at least 2 or 3 of these type of problems on every SAT and ACT, if not more. They really love this concept. It comes up often. Getting skilled at it can mean a lot of points right off the bat for you. Great. Hopefully that was helpful. I wanted to share a couple of last thoughts. We do have an excellent self-directed, self-paced online web program. We're offering a huge discount during this time when many students are working from home. The subscription is usually $199. It's 50% off if you use the code FUTURE. So just go to our website at the URL below. At the cart, you can put in the code FUTURE and get 50% off for this self-paced program you can use for the duration of your prep over the next year or more as you prepare for the SAT and ACT. We also have excellent live online classes where we do similar instruction that I just showed here, except it's full-length classes. You can sign up for these right on our website, methodtestprep.com/classes, pardon me. And tomorrow, on Friday, the 27th, at 1 to 2 p.m., we're going to have a great online class. It's only $20. For $20, we're going to be looking at Algebra 1, a quick overview of some key concepts on linear equations and quadratic equations. If this is something you've been struggling with, or an area that you want to get a little more confidence on, a little more familiarity with, as you move through your math class, this could be a really excellent use of your time tomorrow from 1 to 2. All right, go to that URL I've put here in red, or just to our website. You'll see this also on our Facebook page, so you can sign up when you'd like. Reach out to us with any questions. We have a lot of good information right on our blog, especially about college admissions, the SAT and ACT exams, and some advice during this time as schools are transitioning online and thinking ahead to the next few weeks and months. Hopefully that was helpful for everyone. We'll be here again tomorrow at 11 o'clock. My colleague Kevin Dennis will be showing some strategies for the SAT and ACT. Hope you can join us. Hope everyone has a great day, and we'll see you soon. Hey, John, good question. Sometimes you'll want sometimes you'll want to know what your cost is before you sign a contract. And just a reminder, the class tomorrow, as all our classes are, is interactive. So if there's a question that comes up, you can't really ask a YouTube video, but you could ask our instructors and we can explain a detail to you or look at something more in depth. All right, have a good day, everyone.